Hey, how's it going, everybody? Welcome back to the channel, New Generation HVAC. And in this video, I'm going to go ahead and talk about heat transfer, absorption, and rejection. Where do we find heat absorption and where do we find heat rejection? So before I go ahead and go into the heat transfer, I'm going to go ahead and explain a little bit once again about the four major components that make up our air conditioning system. That is my compressor, my TXV, my evaporator, and then my condenser, right? So this system right here, once again, is tied up with my refrigeration line sets, and flowing inside of my refrigeration line sets is my refrigerant. Now, whenever we talk about heat transfer and absorption and rejection, we have my low side of my system and we have my high side of my system. Let's go ahead and start talking about heat absorption in my low side of my system. Now, how do I get heat absorption in my low side of my system? Well, whenever you go ahead and talk about heat absorption and rejection, whenever there's a heat transfer, remember this, there has to be a difference in temperatures. One has to be hot, one has to be cold. And always remember this, hot loves cold. So wherever something is cold, heat is always attracted to it. That being said, pay attention to what the temperature of my refrigerant is inside of my evaporator. So imagine your own home, or in this case, imagine my home or your home is at 75 degrees, but you want that temperature to be at 72 degrees. So what is it that we normally do? We go to our thermostat, we go ahead and we drop it down to 72 degrees, and then we go ahead and sit down, right? And we go ahead and wait for that air to be conditioned. Well, what happens in that process? What's actually going on to the heat inside our home, and what is my air conditioning system doing to bring down the temperature to where I'm more comfortable at 72 degrees? Well, what happens is when your air conditioning system turns on, the blower wheel, in this case your blower assembly or the fan that pushes the air through the whole system inside of your house, is going to go ahead and turn on, and it's going to go ahead and force your indoor ambient air through the air handler. Your air handler is a system that's inside of your home. It could be in the attic or it could be in a closet space, but that's your air handler right there. So what's going to happen once again is that your air that's 75 degrees inside your home, that's known as your ambient air or your ambient air temperature, that air is going to be forced through the evaporator coil. And so in order for me to have heat absorption, my refrigerant inside of my evaporator needs to be colder than my ambient air. So that means that my refrigerant needs to be at, let's say my coil temperature is at around 45 degrees. So 45 degrees is my coil temperature. My ambient temperature is at 75 degrees. What happened was there was heat absorption. Where did the heat go from my ambient temperature? Well, once again, it went into my refrigerant, and then coming out of my supply is coming out at about 55 degrees. So there we have that heat absorption, and there was a heat transfer from my ambient air into the refrigerant. Now that refrigerant is going to go ahead and take all that heat that was absorbed, and it's going to go ahead and send it all the way into my compressor. Before it goes into my condenser, it goes into my compressor. It is very important that it goes into my compressor because the compressor does something very, very important in order for there to be heat rejection. Now, remember how I mentioned that there needs to be a difference in temperature? Well, all that heat, it needs to be transferred somewhere else. So that means that when it comes back, in this case, when my refrigerant travels back into my evaporator, it's going to go ahead and be ready to absorb heat once again. So what happens is that as it goes into my compressor, my pressure is being picked up. And so if my pressure is being picked up, so is my temperature. All right. Now, imagine my outdoor temperature at around 90 degrees. So my ambient outdoor temperature is at 90 degrees. So that means that my refrigerant needs to be brought higher than 90 degrees in order for there to be a heat transfer. So what does the compressor do? Well, there's already the refrigerant is coming back a little bit hotter than 45 degrees. So let's say it's traveling back at about 60 degrees, 55, 60, but it still needs to pick up the temperature even higher, because if that 60 degrees comes in and it goes in through that same coil and there's no rise in pressure and there's no rise in temperature, then this ambient air will do nothing. So that means that the compressor is going to go ahead and squeeze the refrigerant, and it's going to pick up the temperature at to about 115 degrees. You see my coil temperature right here for my outdoor system? The temperature is at about 115 degrees. So now as this air from this fan is going to go ahead and force all that air into the coil. As that air touches the coil of my condenser system, the ambient air is now going to act like the refrigerant. The ambient air is going to go ahead and absorb all that heat that was absorbed over here in my evaporator. And so what's going on is that the refrigerant is now rejecting the heat. Is rejecting the heat to something cooler. So you see how that works? You see, now that's why this 110 degrees is the air we feel that whenever we pass over the condenser and we put our hand over it, that's the warm air that we're feeling. That's the air that's being rejected from my refrigerant. The heat, that same heat that was absorbed from inside my or your home. And that's how heat transfer works. That's how heat transfer works inside of my air conditioning system. There needs to be a difference, once again, in temperatures. So we have a difference in temperature here, where my coil is colder than my indoor air, and here my outdoor air is colder than my coil. Okay, and then after that heat transfer happens and you have heat rejection here, then it goes and it's being sent to my TXV. Now my TXV works opposite as my compressor. Now it's dropping the temperature. As it's dropping the temperature, it's also dropping that pressure. And the cycle happens over and over and over again. I want to go ahead and thank you for sticking around this video and watching this video. If you went ahead and liked this video, make sure you go ahead and leave a thumbs up. Subscribe for future videos. I'm going to go ahead and continue talking about the refrigeration part of my air conditioning system. So if you want to go ahead and continue to learn more, so you can go ahead and continue on your HVAC journey.